Okay, so um, let me check I'm live or not. Wait. Okay, I'm live. Uh, okay, so in last past live stream we have done the data subsampling and we ensured the data subsampling would not break the kernel. Okay. So okay, now we are doing the a little part of exploratory data analysis right here. Okay. Okay, we are gonna do today in today live stream. Our goal is to do deep exploratory data analysis and TM score metric implementation. Okay, we're gonna also implement the TM score metric. Okay. Okay, so our let's define our goal. Hope my voice is coming. Yeah, it is coming. Okay, so let's create our focus today. First of all, deep EDA, and the second focus will be TM score metric implementation. Okay. Okay, so that will be our deep focus now. Okay. Okay, so now we are gonna start our deep EDA. Before that, the understanding of distributions, length, and then compositions, and then building our scorer is very important. So the in this first cell, we're gonna try to understand the distributions, length, and then compositions, and then trying to build our scorer. Okay. Okay, so now we have to start the coding. Before that, wait, let me. Okay okay so okay, now let's start the next cell. Okay, phase 2 next cell. Phase 1 is completed. Let's define phase n. This will be phase n. Okay, so now the current focus is to. Okay, so first of all, let's import the essential libraries. Import matplot leaf.pyplot as plt. This is for the data visualization. Important important for data, important for EDA. And then we wanna import collections. Okay, so that's the main imports we are gonna do in the that's the main info imports we are gonna do in our first cell. Okay, so I will just tell you what import collection is that. Okay. Okay, so imports collection module is a part of Python standard library. Offers container data types that provide alternatives to general purpose built-in container like dictionary, list, set. Okay, so why we use collection? Okay, to to get specialized container to get special okay to get container like list, dictionary, and this type of thing. Okay, and now we are gonna move into now our import is complete. This is for container and this is for the data visualization. Okay, and now we are gonna move into the next line where we load the sequences metadata. First of all, train sequences equals to pd dot read csv pd dot read csv base di. What's our variable name which we define? You can say see base dir. There is a base dir, and then inside the base dir we have train sequences dot csv train sequences dot csv train sequences dot csv. Okay, now validation sequences pd dot read csv, which will be base dir. Inside the base dir validation sequences dot csv validation sequences dot csv. Okay, what we do here, in all the instance metadata. Okay, and now we already loaded train sequences, validation sequences. Now the left sequences is test sequences. Okay, and then test sequences. Now the final is test sequences uh, pd dot read csv base dir, and inside the base dir uh, we have we have the test sequences dot csv. Okay, now the all three sequences metadata is load. So now let's print f the length of the training sequences is the train seq of the validation sequences is the val sequences, and then the print sorry, I forget to add length function here. Okay, fine, what I am doing. Length of the training sequence, length of the validation sequence. Okay, the length of the test sequence is f string, and inside f string length of the test sequence. Okay, now we have printed the length of these sequences now. Okay, now let's just check the validation columns and then trend sequences column. Wait, just we have to open the file and then we have to check its column. Okay, print. Okay, trend sequences or columns print f. We have the test sequences dot column. Okay, okay, now okay, okay, we are just printing the length of the sequences and columns of the sequences. Let's check the script. Okay, print fa where I did the hmm, where this one. Okay, sorry, my mistake. Okay, there is all chrome, which is target ID, sequence, temporal cutoff, description, stoichiometry, all sequences, ligand IDs, ligand smiles. Okay, index is target ID, sequence, temporal cutoff. Okay, now the next thing we have to do is the sequence length distribution. Okay, sequence length distribution, what that exactly mean? Okay. Now I'm gonna write why this matter. Because longer RNA harder to fold, right? If our RNA is longer, then it is harder to fold, right? If the RNA is longer, then folding will be very hard. If test has length not seen in train, our model will struggle. This is the number one thing. Okay, if test has length, if test has length not seen in train. Okay, if our test has length and not seen in our train, then our model will obviously struggle or bit. This is hashtag one priority. Okay, this is hashtag one priority. Okay, now let's write a script for sequence length distribution. Okay, now the thing we are gonna do is we are just creating the sequence train sequence and adding a column sequence length. Okay, sequence length will be train, oh sorry, train sequence our sequence dot str dot length, its length, and then value sequence will be, what is our variable name, wait, let me, value sequence will, okay, value a sequence and sequence length will be the new column, and then value sequence dot str dot length. Okay, let me check it have the sequences column or not. Yeah, you can check the sequences column from there. Just wait. Hello. Okay, value sequence will be the sequence column, and then its folder. Okay, and now the test, we need the test sequence also, test sequence length. Let's create a sequence length folder, and then test sequence, and then we need sequence column dot str dot length. Okay, now we got our three length, and then now the next thing we are gonna do is that we create figure and our axis, our x-axis and then y-axis, and we are gonna plot subplot plt dot subplot, so it will be 1 and 3, and it will be figure size of let's say 18 and 5. Okay, 18 and 5, and then axis of 0 dot, we are gonna make the histogram plot here, histogram plot, and HIST trend sequence, and we trend sequence. We are just getting the trend sequence, and then length sequence, length column here, and the beans will be how many? 50. The beans will be 50. Okay, and let's choose color. Let's keep it like this, it will look professional. Okay, now beans will be 50, and then color will be stel is still is color will be still blue. And then the next thing we are gonna have it is, let's keep it here, color is the still blue, and then edge color will be black. Okay, edge color will be black, and then the next thing will be alpha. Okay, alpha will be 0.7. Is that enough? Yes, it is enough, I guess. Now we're gonna set title axis of 0 dot set title. What we're gonna set the title, sorry, let's set the title trend sequences length, trend sequences. Basically we are doing the core part of EDA data visualization. Okay, let's add this, and equals length of the and equals the length of the train sequence, and then we are gonna close this bracket, and then we are gonna just do this, and now we are all set. Okay, with no syntax error. Now we're gonna just set the x level dot x label, sorry, set x label length, the length LEOTIDS. Let me explain what is nucleotides. Nucleotides. The essential building block of nucleic new CLEIC nucleic acids. Okay, RNA. Okay, now y level will be count. Axis of one dot histogram plot value sequence. Just we are doing the same histogram plot with the value sequence. Okay, seq sequence length. Beans will be 50. After that, color will be Sri green. Color equals Sri green, C green. Edge color equals, edge color will be what? Edge color will be black, and then our all far will be on what ratio? 0.7. Okay, for the sequence length it is done. Let's add the color coral. Okay, coral. Let's add the coral and then edge color black perfect, pins 50 perfect, edge color black perfect, alpha pins 50 perfect, color perfect. Okay, now we're gonna move into the axis 0 is done on the 0 index. Now axis 1 index is done. Now the setting the axis 1 dot set title. Let's set title. Okay, validation sequence length, validation sequences length, which will be uh, n equals length of the val sequence, okay, n equals set length of the val sequence. All done, there is no syntax error. Now we're gonna define the x level, set x level x level, sorry, x level, x level, which will be, oh, I mistakenly execute it. X level will be length nucleus, axis 1. X level will be length. Okay, that's same. Let's say nu here. Now we are gonna moving into axis 2. On the axis 2, what we hold, access to the hist, we have train sequence. Okay, we have the train sequence, sorry, not train sequence, we have the test sequence, which are gonna create the plot, train sequence, and then our sequence length, and then our beans will be 50. The beans will be 50. Okay, and then the color will be, let's say, sea green for it. Color will be sea green. Its color will be black. Perfect, black is the perfect color. And then black is the perfect color for it. Oh no, my code is looking like east or west, north is west. One block is there, one block is there. I have to do one thing, just I have to do the take the all part into left side. No, let's maintain this level. Okay, is that similar? Yes, it is. Let's take all block into that section. Is that perfect? Yes, it is. Let's take it here. Okay, that's the subplots. Okay, subplots, and then still blue. Okay, okay, now it is going well. Alpha ratio will be 0.7. Okay, now the plot will finish there. Now we have to do one thing, access to dot set set title, the test sequences length, which actually the length of the sequences is nucleotides, the essential building block for RNA. Okay, or you can say RNA. Length of the length of the length of the test sequence, sorry, test sequence, length of the test sequence, length of the test sequence. Wait, what I'm doing here. Okay, just close it like this. Access to dot x level is again the length, or you can say nu in the form. Okay, now you have to just plt dot tilt is spelling tight layer, sorry. We have to just type the tight layout function, layout plt dot tight layout, and then after tightening layout we have to just show the plot. Okay, PRD dot slow. I'm not sure my visualization will even work or not. It says syntax error again. Wait, I have actually syntax error. Okay, figure size. After figure size, what I did here, actually I needed to close what. Invalid syntax where figure access. Wait, this should not happen. Why? That is perfect. What happened? What happened? What happened? What happened? What happened? What happened? Okay, let's just do this. Now let what? Wait. Attribute error. Okay. Alpha access object has no attribute x level. Wait. Alpha access. What I did? Oh, sorry. Set x level. Set x level. Okay. Set the x level. Yes, worked. Now let's carefully analyze the graph. Okay, train sequences. Okay. Now this length of nucleotides. Okay, let's close there for a second. Let me analyze the image. Okay, at train sequences length total 5716, right? And then we have, okay, that's a count. Wait, why we set the, it's all count, it's all length of the nucleotides. Okay, good. Okay, now let's wait, before that we have to just print the, let's print the important stats. Okay, print the important statistics for name df, for name df in, we have to just do this. And what I'm not, what I'm doing, I'm even not sure of it. We have to just iterate from the, from the train to train train sequence. Yeah, I'm getting that. Train sequence, and then our in name. Okay, in df our value, and then our val sequences to print the key statistics of it. Value sequences, value sequences. Okay. Okay. Now we can just skip that, and the next will be train test validation. That is last one is test, and then test sequences. Okay, nothing to worry about it. It is all fine, perfect. Test sequences, and then we have to stop this, and then we have to iterate over this. Okay. Now the thing we are gonna do is finding the minimum and maximum value, and then median. Okay, and then median, and then mean. Okay, from the data. This can help us to prepare the best EDA on the dataset to get actual better results on the training. This is a very important phase of before the model training. Our code base looks pretty solid. Okay, now let's calculate the minimum value of it. F the minimum value of the okay, minimum value is the df sequence length. We just do one thing here, look closely. We just added all the sequences length in just df data frame. Okay, sequences length dot mean function dot mean. Our name, let's just do a bit more better formatting here. Okay, now let's again calculate the print f. The maximum value is the slash and the name, and then the data frame of and then the data frame of sequence length, sequence length, sequence length dot max. I'm in a live stream. Df sequence length dot max. Okay, now let's get the median. Wait, what I'm doing? Now getting the mean. Wait, what I did? Okay, so guys, this is it for today live stream. So we will continue maybe tomorrow. Okay, so in this today live stream, uh, we just did two things.